Here we go. We have a question here. Construct the lexicographical largest valid sequence. So you have given an integer n. We need to find a sequence that satisfies all the following rules. The integer 1 occurs once. Each integer between 2 to n occurs twice. For every integer I between 2 to n, the distance between the two occurrences of I is exactly I. For example, let's take 3. So the distance between the first occurrence and the last occurrence must be 3. And we already know how to find the distance. And what is a lexicographical largest number? This is just the definition of the lexicographical largest number. And let's take a test case for this. So first we try to place 3. This is the valid answer. And first we try to place 3 because that will make a largest lexicographical largest number. Then we try to place 2 on this location, but the next 2 must be on this location, but 3 is already there, so 2 cannot be placed. 2 can be placed here. So the next which is the last occurrence will be on this location. Then 1 is here. This is the largest number. For this test case, this is the valid answer. Now we know how to find the lexicographical largest number. Now let's try to build the approach. I will take n as 5 and we'll try to find an approach. Let's take n as 5. Then we have an array. Let's say this is used array. So this is Boolean array. 0, 1, 2, 3, 4, 5. Every value is not used. We have not used any value. Then we also have answer. This is the answer. And what will the answer length? This value occurs once and every value occurs twice. So can I say it will be 2 cross n minus 1, which is the 9. So we have answer length as 9. So its length is 2 cross n minus 1. So we have 9 elements, 9 values. So 0, 1, 2, 3, 4, 5, 6. Let me 1, 2, 3, 4, 6, 7 and 8. So we have this array, and we'll try to make this array as large as possible. So we have recursive function. We're gonna use backtracking. So in this recursive function, we're gonna pass some values. So first is the used array, then the corresponding index, which will denote current index in the answer. Then we also need answer. Maybe I will pass n also. Initially our index is 0, so I am on to this location, and we are trying to make this array as large as possible. So we will try to start from backwards. So have I used this number? No, I have not used this number. So let me change the color. So we're gonna use this number and place it here. So I have used 5 here. So first 5 is here. The next 5 must be here, which is, if I placed first value on the ith place, the next value must be on num plus ith place. So num plus ith place is empty, so we will place this. Next we have placed value, and we will jump on to the next index. So we are on to this index. Have I used this element? Yes. Have I used this element? No. So we can use this element. First of all, check, can I use this element? If I place 4 here, the next 4 will be on to this location, but this is already filled, so we cannot use 4. Can I use 3 here? If I place 3 here, the next 3 will be onto this index, so we can place 3. Yes, 3 is a valid element for this location, so we have used 3. Next we jump onto the next index. So have I used this element? Yes. Have I used this element? No. Can I use this element? If I place 4 here, the next 4 be onto this index. Yes, we can place 4. 4 is a valid element for this location. Next we are onto this. Have I used this? Have I used this? Have I used this? Yes. Have I used this? No. Can I place this? If I place 2 here, the next 2 will be onto this, but the that index is already filled, so we cannot place 2. Can I place 1 here? Yes, we can place 1 here. 1 is a valid we can say element for this location, so we have used 1. Then we jump onto this index. This index is already filled, so we jump onto next index. Already filled. Then this. Can I place this number? No. Can I place this number? No. Can I place this number? No. This is already used. Can I place this number? Yes, we can place. Can I place this number? So if I place 2 here, the next 2 location will be out of range, so we cannot place 2. So we need to do backtracking. So 1 is not a valid for this, and we cannot go back, so we need to do further backtracking. So 4 is not a valid 4 is not a valid element for this location. If I place 4, we cannot place more values. Can I place 3? No, 3 is already used. Can I place 2? No. Can I place 1? Let's try. We can place 1, and let's try to make our array. So we are onto this location. Can I place 5? No, already used. Can I place 4? Yes, we can place 4. So if I place 4 here, 1, 2, 3 and 4. So next 4 is on this location. So 4 is a valid element. Then this index is already filled. This index is already filled. Then this index. Can I place 5? No. Can I place 4? No. Can I place 3? No. Can I place 2? Let's find out. We can place 2. The next index is this, and we have used 2. Then we are jump onto this index. It is already filled. Then we jump onto this. Our I, this is the base case. If our I reaches 2 cross n plus 1, which is 9, it means we have filled each and every value. We have made our array, so we will return true from this point. So let's find out if this is the expected answer. 5 3 1 4 3 5 2 4 2. Yes, this is a valid answer. Now let's code this. Now let's continue. So we need used array. This is the boolean array. Used new boolean. Its length is n plus 1. Then we have a answer. Its length is 2 cross n minus 1. And we have a recursive function answer I used and n. Then we have a boolean. Its return type is boolean. I used this boolean and n. Then we will pick a number, so n, and number is greater than 0, number minus minus. So we are placing on ith location number, but we first have to verify, can I place this number? If I place, first of all, if your number is 1, so we only need to place one number. So just place 1. I is equal to num, we can say, and we are passing answer plus 1 used n. So if we are getting true, we will just return true. If we are not getting true, we just place 0. And as we have used this number, so we have to mark it used num. We have used our current value. Then for the backtracking part, we will mark as unused. Before placing the number, we have to check if this number is already used. So just move to the next value. This is for 1, but for 2 to n we are placing 2 occurrences. First occurrence will be on ith location, and the second occurrence will be on num plus ith location. So we have to check, is nums plus I less than n? If this is true, and answer num plus I is not already filled, is equal to 0, not already filled, so we will fill it. First this, then this, then we will call our recursive function I plus 1 used n. If we are getting true, we just need to return true. Then for the backtracking, place 0 and place 0. Then we need our base condition. If our I reaches num's length, just return true. Then we also have one base condition. If our ith location is already filled, means it is not equal to 0, then just not already 0, jump to the next index, I plus 1 used and n, and let's run this. And we have made a mistake. This is 0. We also need to return our answer. Then I hope it will work. No, we are not passing return. Return false, and nums. This is not nums, this is num. Num is our current number. And yeah, we have made a mistake. Let's find out what we have done wrong. First of all, we are on to 0. Then we are starting from backwards. For num is equal to 1. It's easy to just print our answer array. Print it. Zero, 0, 0. Then it is not on to 3. We have to start from 3, and it is not on to 3. Why it is not starting from 3? Num we are passing n. Our n is 3, so it is 3. Then num is not 1, and we have not used 3 either. Yes, we have not used 3. Then 3 plus 0. Yes, 3 plus 0. No, this is not n. This is answer length. Num plus I is answer length. This is a valid index. Yes, and it will submit it also. I think it will give you OLE. Okay. So we have solved this question. And let's talk about time and space complexity. So this is the code. Let's talk about time and space complexity. So for the time complexity, for this index, how many choices we have? We have that many choices. So we have n choices. Next we are on to this index. How many choices we have? We have n minus 1 choices plus n minus 1 no multiply n minus 1 multiply n minus 2. So we have order of n factorial choices. This is the time complexity. What about the space complexity? Space complexity is only order of n, we can say. So that's about it. Your editorial is visible. Time complexity, space complexity, yes, and we have solved this question. And thank you all for watching this video.